Before viewing video lessons, it is important to read the textbook using the learning guide as your turn-by-turn directions. Then use the learning guide to take organized notes in your own words with examples and pictures. Human memory. This information covers mainly Chapter 7 of the textbook. In this unit of material, we'll continue looking at the interaction between biological, psychological, and socio-environmental factors in understanding psychology. The focus is on memory, which is a psychological construct that includes behaviors, thoughts, attention, and motivations, which are also psychological factors. There are biological factors related to your senses, the hippocampus, the cortex of the brain, and neural circuits in the nervous system. Finally, memory is also influenced by cues from our environment and misinformation and distraction. So we'll be looking at all of these factors and how they interact to help explain memory and psychology. When it comes to memory, there are basically three questions we all have. How does information get into memory? How is it maintained? And how can I pull it back out? As a college student, you've probably fantasized about having some sort of port installed on your head that you could just plug in and download Psych 101, kind of like the Matrix. Unfortunately, we don't have that technology yet, so we're going to be focusing on how we have to work to get information into our memory. We're also going to be looking at how we try to hold on to it, and then again, as a college student, how you pull it back out accurately on test day so that you can do well on your exams. In order to answer these questions, we're going to look at a couple of different models for conceptualizing the process. The first model is going to compare our memories to a computer. So when we look at how we put information into memory, we are calling that input. For a computer, you can input memories or code using a keyboard. So if you're typing up a paper for a class, you're going to be typing the keys of your keyboard and creating a code. Now, the computer does not store your paper using alphanumeric characters. It's going to convert what you're typing on the keyboard into binary code, which is a code the computer is capable of reading, understanding, and recording. Binary code is zeros and ones. So first, the computer inputs, then it encodes, and once you've gotten your paper typed, you typically store it. So when we store our papers on the computer, we would save them to a file, and that file would be stored on a device. It could be the hard drive of my computer. It could be a portable storage device like a flash drive or a thumb drive, but it's going to be physically stored on some form of media. Finally, you want to retrieve those memories. So if you've typed your paper up on one computer, it's been encoded, saved, and stored on your flash drive, and then you come to the library, for example, to get some help on your APA-style citations, you are going to retrieve that file, and the computer is going to convert the code of zeros and ones into, hopefully, your complete and accurate paper. So if we look at memory from this standpoint, we can compare that to how human memory works. So what we're going to be focusing on first is the encoding and storage piece of memory. So here's our computer analogy again. And now we're going to add in how this compares to people. As I mentioned before, people don't have ports stuck in the side of our heads that we can just download information into our brains. We actually have ports all over our body. So our sensory input devices are our senses. We have sights, sounds, smells, tastes, and touches. All of your sensory organs, to include ones that are on the side of your head, are putting the information that's going on outside into a translatable code that can be stored and retrieved later. So right now, you are seeing what's on your screen. You're seeing the slide. That is a sight that's coming in. You're listening to the sound of my voice and the words that I'm saying. That is the input. Encoding is going to be when that raw sensory data is transformed into a code that we have the capability to store and ideally retrieve. So once the sensory information has been translated into a memory code, then we're going to retain it for a period of time. And we actually have different types of storage, much like your computer has different types of storage. And so sometimes that storage is very brief and short term, and other times it's essentially permanent. So to explain why there's differences in the length, just want you to think back about those computers again for just a minute. Most people know that their computers have two different types of memory. There's kind of the permanent storage memory of my hard drive on my computer, and I can save my paper on there. But if I don't have my paper open, it's just kind of sitting in cold storage back in some, deep layer. If I'm working on my paper or typing my paper, it's in a different type of memory on my computer called working memory. And that's the memory that is being used for all the active processes. So for people, we have 3 different types of storage system. The theory in psychology that uses these analogies related to computers to try to understand memory and thinking is called information processing theory. And so they've divided up memory into 3 different types of storage. There is a sensory store, a short-term or working memory store, and there is a long-term memory store. So to help understand how these 3 memory stores work and affect storage and retrieval, we're going to take that input, encoding, storage, retrieval model and combine it with information processing theory's model of the 3 stores. So here is our memory model. It's going to start with input. We are continuously experiencing sensory input. Sensory information is constantly coming in through the sights, sounds, smells, tastes, and touches from my environment. That information is going to be encoded and stored through 3 different storage or stages of memory. The first place that sensory information goes is called sensory memory. Sensory memory is the raw sensory data coming in from the outside, and it's a very, very brief preservation of that input. So all of the things that you're hearing, seeing, smelling, tasting, touching come into sensory memory, and then if nothing else happens to them, they kind of fall out quite quickly in less than a second. However, if you pay attention to that sensory input that's coming in, it moves into the short-term memory storage space. Now, in order for this to happen, we have to pay attention. So if we pay attention and it moves to short-term memory, then it has the possibility and chance to move to long-term memory. Long-term memory is where most of you are hoping that your memories for this class make it. Long-term memory is the type of memory you access and use when you're taking a test in a class. But before we talk about long-term memory, it's important to look at how attention impacts what we're able to remember. So when we talked about variations in consciousness earlier, we talked about how you can have two different types of alert and awake, two different types of awake brain waves, I should say. There are beta brain waves, which is awake, alert, and focused, doing problem solving. And then there's kind of relaxed, daydreamy kind of brain waves called alpha. Well, it turns out that we have to have focused awareness, i.e. beta brain waves, on a selected stimuli in order to get that memory code to short-term memory, which is required to eventually get it into that long-term memory store. So if you are drifting off into alpha right now, watching this video, you're finding it a little boring, you might be a little tired, or maybe you just need a little mental break, you're not learning. So pause the video and then come back to it when you're ready to focus. So if you're focusing right now, then what you're doing is you're moving this information that you're seeing and hearing into short-term memory, where it has a chance to eventually make it to long-term storage. If you watched this video in alpha and you weren't really focusing, then you wouldn't be able to remember what it was about. This is one of the reasons why I encourage you to use the learning guides and take notes while you're reading and watching videos, because taking notes, particularly in your own words, keeps you in beta brainwaves. Now, one last point about attention. Some of you may say that you have the ability to multitask or focus on more than one thing at a time. What the research shows is that this isn't what happens. When you have the illusion that you are multitasking and doing two different things at once, what's actually happening is you're rapidly shifting your focus back and forth from these two competing stimuli. Think about studying and listening to music at the same time. If you're actually listening to it, you're listening to it and it's the music that you love, you are not focusing on your studies. So if you're reading your textbook while you have your music playing and you catch yourself doing this inside your head, Mama! Ooh! Oh, I love that part of the song. Oh, it's so good. Then you're probably not actually learning anything. Because then you're going to come back to your studies and you're going to say, where was I? What was I doing? Oh yeah, I have to reset and focus my attention. So switching back and forth is ineffective. It makes you go backwards. And more recent research has shown every time you shift your focus off of the task and try to shift back, there's about a 30-second delay before your full attention can refocus on that stimuli. This is why your instructors are always recommending a distraction-free environment, because they want you to have that ability to focus and pay attention. As you learned in the Variations in Consciousness chapter, though, you can only focus for about 15 to 20 minutes at a time, and then you need a break. So now, you need a break.